Hey, everybody. So, over the whole semester, we've been talking about how to find aliens, where they might be, what their environment might be like. Last week, we looked at what their physical construction might be, what they might eat, what they might breathe, what their technological capabilities might be. So, today we're going to talk about how we might actually try to communicate with them. So, here again, we're not talking about just alien critters crawling around. We're talking about intelligent species that we can actually communicate with. So turns out we've been sending messages for quite some time now, and maybe we've even gotten one back. So today we're going to look at how do we send these messages? What form do they take? And would we even know what it was they were trying to tell us if we did get a message from them? So let's get started. Okay, so make sure you've got your class notes out. That's going to be the Communicating with Aliens. That's tool 29. So have that out so that you can be following along as we're going through with that. This will help you out once we get down to the practice later on. So when we're talking about communicating with aliens, one of the things we have to ask is, do they have the technology to communicate with us? So just because they're intelligent doesn't necessarily mean that they're going to develop technology. I mean, arguably, there are two intelligent species on this planet, us and the dolphins. The dolphins have no technology because they don't have any hands. So physiological issues can prevent you from developing technology. I mean, if they're this jellyfish slime that lives in the oceans, they may be intelligent and communicating, but they're not going to have any way of actually building a radio transmitter or some way to actually talk to us, either through a spacecraft or anything like that. The other issue is sociological. Humans have been intelligent for about 20,000 years. Our intelligence actually hasn't changed that much since the Neanderthal days, and a little bit later than that, obviously. But so we've not changed our intelligence in 20,000 years, but we've only had technology for about 150 years. So here we've got this long lifespan of which we've had humans who have evolved. They're intelligent and have the capability of creating technology, and yet it took over 20,000 years for them to be able to actually decide, hey, let's go ahead and do this. So we don't really know what inspires a civilization to develop technology, because we think that it would be some sort of survival mechanism, probably, but would we have to go that way? However, if we're going to be talking to aliens, we're going to need to assume that we're talking to aliens that have technology. Otherwise, there's just no way that we're going to be able to communicate. So then the question becomes, how can we communicate? Well, we're not going to be able to actually travel there. Until we develop some sort of faster than light travel, it's just pretty much not going to happen. So that light speed barrier means we're not going to be able to talk face to face, or whatever it is they have. So we're going to have to send some sort of message to them and then wait to get a reply. Here again, we've got a problem with light speed communication. Even getting a message to the nearest star system to us, Alpha Centauri, takes about 4.5 years one way. So you're talking about, almost a 10-year round trip just to say, hi, how you doing? Oh, we're doing fine. That kind of thing. Another possibility is to send physical objects. Believe it or not, we've actually done this. We've actually sent a number of spacecraft out into interstellar space that could conceivably be picked up by aliens, and they have messages on board. So we'll talk about that in a little bit. And then the big thing, though, is that we're going to rely on transmissions, being able to send this message out. That also means we need to be listening and receiving these messages from them. So when we're going to make a transmission, then we've got to decide, well, what do you want to transmit on? I mean, we've got the entire electromagnetic spectrum available to us. We've got gamma rays, X-rays, ultraviolet, visible, infrared, microwave, and radio. So we can look at the situation. We're trying to communicate over very large distances through the galaxy, and that's going to put some limitations on us. We don't want any competition with other astronomical objects, so you don't want to use a light beam like a laser or something like that, because it's going to get lost in the light of the other stars. Earth, for example, can't be seen from space, from outside of the solar system, because we're too close to the sun. The light from the sun is just so bright that it's masking everything that we could possibly do. So visible light is not going to be a good choice. We also need something that's going to penetrate the atmosphere. So gamma rays, X-rays, none of those are going to penetrate the atmosphere. Infrared maybe comes down to like the height of 747s, but that's probably not going to reach the surface for them. So if we assume that their alien's atmosphere is going to be at least somewhat similar to ours, probably gamma ray and X-ray, and maybe infrared too, are not going to be really good choices, because if they're not listening for it, if they're not out in space monitoring, then they're never going to hear it in the first place. We also need something that's going to penetrate the interstellar gas and dust. That's going to be some of the same issues. Infrared, it gets absorbed by the dust and could get radiated, but then you've lost your message at that point. The other thing is it needs to be easy and inexpensive to produce. Well, we've already talked about how gamma rays probably aren't going to penetrate the atmosphere to begin with, but sending Morse code with nuclear explosions is not going to be a very effective way, because each one of those bombs that we set off, might cost $100 million or so. So that would be crazy expensive and difficult to produce message. So we need something that's going to be really simple that is yet still going to make it all the way to the ground for them. So when we look at the options that we've got here, what do you think the best wavelength would be? So pause the video, think about it, and then pick it back up. Did you actually pause the video? You need to be thinking about these things. So probably your best bet is actually going to be radio. Radio is something that we can pick up throughout the galaxy. It penetrates throughout all of the stars and the gas and the dust. It's going to penetrate down to the surface of the planet. It's easy to produce, it's cheap, doesn't require a whole lot of energy. So it kind of meets pretty much everything we've got. We assume that the aliens are going to go through the same kind of calculations that we have, and they also will arrive at the idea of doing radio. Now, we assume, right? So it's possible that they could be using something else, but by the same token, the same problems that we face, they're going to face too. And so we probably won't actually get the message if they don't use radio. So if you're looking for something from aliens, you're going to look on the radio band. You're also going to send your message out on the radio band. So let's look at the types of transmissions that humans have sent out so far. There are basically 4 different kinds of civilizations that are possible. Type 1 civilizations are going to have nothing but local communication, so just talking back and forth to each other. And that could be radio, like listening to AM or FM radio, television signals, radar, and in particular, aircraft radar. Now, radar stands for radio distance and ranging. So it's a very powerful radio beam that hits the aircraft and then bounces back to give an estimate of the distance and the velocity from that. Well, these things escape the Earth. So it's possible that you could actually detect a radar beam from out in space somewhere. A type 2 civilization has interplanetary communications. So they're intentionally talking to things that are off of the planet. And it may be in orbit around their planet, or it may be actually explorers going off to other planets. So our orbital spacecraft, our satellites, our communication satellites, our geomonitoring satellites, all of this sort of thing, when we talk to them, we're sending a message out into space, and it doesn't just stop with the satellite. It keeps on going outward. So it is possible that an alien could detect that, even though it's not intended for them. It's possible they could see it. Planetary explorers are going to be even easier. If we send twice a week, we send a message to Mars from the Deep Space Network to communicate with our spacecraft that are out at Mars. We've got a number of other explorers that are even farther out in space that we talk to, receive commands to and from. So these take very high power radio beams in order to send that message. And so again, once it hits that spacecraft, it doesn't stop. It keeps on going and moves on out into space. And so it could conceivably be detected by aliens. Here again, same thing could happen for us. We could detect their communications coming to us. Even if they're not trying to talk to us, we could actually detect some of the things that they're doing. A type 3 civilization is kind of the gold mine. This is an intentional beacon. This is somebody saying, hey, look at me, we want to talk to aliens. So these are deliberate attempts to communicate with aliens. And may not know where any of these aliens are. We don't. But we're sending out these beacons saying, hey, if anybody's out there, come and talk to us. And it's possible that other alien civilizations would do the same thing. Now, the 4th type, interstellar communications. These are civilizations that actually have interstellar colony worlds. So they have established, so for us, for example, maybe we've established a colony on Alpha Centauri, on one of the planets orbiting Alpha Centauri. So we would then could be communicating back and forth between those. Obviously, that's going to be extremely high power. Basically, that's exactly what you want for detecting alien transmissions back and forth, is you're going to see these things that were transmitted literally between stars from there. So which type of transmission do you think Earth is? What type of civilization are we? Type 1, type 2, type 3, or type 4? Pause the video, think about it, and let's see where we're at. Well, we've certainly had local communications. Actually, we've become a little bit quieter over the past 20 or 30 years or so because of the invention of cable television. Television signals, broadcast television, is actually a very strong radio beam, and so can actually be detected outside of our planet, outside of our solar system. But as we've moved towards cable, we've actually gotten quieter as a result. So we're actually a little bit harder to detect from just purely local transmissions. However, ever since the late 60s, we've had a very extensive satellite network. We've been communicating with our explorers that are going through the solar system. And so we're sending out more of these beacons. So we've definitely surpassed type 2. And then, as we're going to see, we have actually sent intentional beacons to aliens out in space. So we're going to look at some of the messages that we've sent. A quick review, though. The first type 1 transmission from Earth that was capable of being detected outside the solar system was actually Adolf Hitler's address to the 1936 Olympic Games in Berlin. Joy. So we made a really great first impression with that, I'm sure. So that transmission is currently 80 light years from Earth. So that's the oldest transmission that could possibly have been sent out. So nobody outside of 80 light years has any chance of being able to detect us because the signal just hasn't reached them yet. So they can't look at us and detect us from afar until they get this signal from us. It's the old needle in a haystack problem. So when people ask me, Kilo, are there aliens out there? I say, absolutely. There is basically a 100% chance that there are intelligent communicating aliens out there. I say, well, have they come to Earth? Not a chance, because there just hasn't been enough time. It's only been they have to be within 80 light years of us for them to have ever had a chance to actually see that this was a signal. And then did they actually figure out what it was from there? So, and then as I mentioned, actually, we've become less of a type 1 civilization because we've become quieter due to cable television. So this is Sputnik. This is the first Earth orbiting spacecraft. It was launched by the Russians, then the Soviet Union, on October 4th, 1957. This was a fairly big deal. It was really just a radio transmitter sitting there going beep, 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 beep. What was so earth-shaking, if you're part of the fun about it, was that here the Russians have something that's permanently up in space that's flying over U.S. airspace. And you got to remember, ballistic missiles hadn't been invented yet. If you wanted to drop a nuke on somebody, you had to actually fly an aircraft into their airspace and then drop a bomb on them. And there was no way that that was going to happen because we had our own defenses that would have shot that down. Well, now here the Russians are saying, ha, I could have killed you. Ha, I could have killed you. And so this is what triggered the space race as a result of that. Currently, we have over 3,000 satellites. It's actually becoming a problem. And some of these satellites are dead. We're getting almost a junk belt up there. And nobody has a real plan for how to deal with that. Then also, as I mentioned, when we're talking to Mars, we talk to Mars twice a week. And we send we basically squirt all the commands from the Deep Space Network out to the Martian spacecraft. They receive it and they execute the commands for those 3 or 4 days and then send their results back. So we've got this network that's being beamed out. So these are our major type 2 transmissions. For type 3, and I'm going to move this over here so that you can see what's going on. So for type 3, this actually was the first radio beacon that we had ever sent to aliens. And we encoded it using a method that you're actually going to be using in your practice. So this was sent on November 16th, 1974. This was sent from the Arecibo radio telescope, the one that just recently crashed and destroyed itself, basically, when it failed. So this was the largest radio telescope in the world. And it's actually, in Puerto Rico, it's built into the valley. It takes up the entire valley. And you point it just by the Earth turning from that. So it's an extremely powerful radio telescope. And so they beamed it out towards M13, which is a globular cluster. That's an ancient collection of stars that's orbiting the disk of our galaxy. These stars are extremely old. It's a possibility, if they have any aliens on around one of those stars, well, they're going to be much more advanced than us because they've just simply been around longer. However, the message isn't going to actually arrive at M13 until the year 25974. So we got a little ways to wait for that one. Really, it was just a convenience target. They were having a ceremony to commission a new instrument at the telescope. And so M13 was in the right place to do it, so they just squirted the message up to them. There wasn't any real intent to talk to anybody. However, it's possible. You never know. So let's look at what this message means, because we had to think long and hard about how we would send a message that they would actually recognize. And you're going to see this in the practice again. So we start out with the binary number system. Let me back up here. We start out with the binary number system. So binary, remember, is 000110 0 or 1011 100, so on and so on, that sort of thing. We think that that's probably the system that's going to be most universal. I mean, we use base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because we happen to have 10 fingers. But there's no real guarantee that any aliens are going to have 10 fingers. In fact, there almost certainly aren't. So we don't know what base number system they would use. However, everybody understands the idea of on and off. So we can say, here's our number system. And so we're basically saying we're going to use this just strictly using on and off. When you're doing your practice, you're going to see we've got beeps and clicks. And so you've got to decide, is a beep an on or is a beep a click from that? So here's our binary number system that we use for all of the rest of the message. Then here we've got if I can get my PowerPoint to cooperate. Here we've got the atomic numbers of hydrogen, carbon, nitrogen, oxygen, and phosphorus. Well, why would we choose those? Think about that. Well, these are the elements that make up us. So basically all organic molecules are made of hydrogen, carbon, nitrogen, oxygen, and phosphorus. Now, they aren't going to call them hydrogen, carbon, nitrogen, and so on, but certainly they're going to be familiar with the atoms there. And if they are technologically capable, they're going to know that hydrogen has 1 proton, carbon has 8, and so on. So they're going to recognize it. So we're telling them what we're made out of. And that's one of the things that you are doing when you were describing your alien, is you were looking at the atmosphere, you were looking at what was available on the planet, and that's what you have to make aliens out of. And so you could figure out, what their composition is. So right here, this is the hydrogen, carbon, oxygen, and nitrogen. And right here, these are the building blocks of DNA. These are the amino acids that make up DNA. And then we've given them the structure of DNA. So they now know exactly what we're made out of and how to kill just us while leaving everything else on the planet. In retrospect, maybe that wasn't the smartest thing we could do, but it's out there now. There's nothing we can do for it. And to make it even easier for them, we told them exactly how many people were on the planet in 1974. So this is the population that was there. This is what we look like. And this is the height of a human. Now, it was sent out in multiples of 21 centimeters, which is the wavelength of the radio beam that we sent out. Why we chose 21 centimeters, if you take 112, you'll see this, but 21 centimeter radio emission is an emission that's characteristic of hydrogen, which of course exists throughout the universe. Most of the universe is made out of hydrogen. So if they are observing the universe, they are certainly aware of hydrogen. They are certainly listening on the 21 centimeter band. So since we know that the message was sent in 21 centimeter radio, hopefully they'll be able to figure out, oh, this must be the height. So that tells them how big we are. And we even told them where to find us. They obviously know which star it came from, but now we're telling them which planet we came from. So here's our solar system. This is the sun, Mercury, Venus. Earth is highlighted here. Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, which is a planet, damn it. And then here's the picture of the Arecibo telescope. I never understood why they had it pointing down instead of up, but there it is. And right here is the diameter of the dish, again in those multiples of 21 centimeters. Let me slide this back over here. So other transmissions that we've sent, we have beamed a transmission to this planet right here. This is Gliese 581G. This is one of the first habitable worlds that we found. So this planet is basically Earth-like. It's got a little bit higher gravity than Earth, but this is certainly an excellent chance for there to be aliens here. Not only that, they're orbiting a very small M-type star, and so this planet would have been around for a very long time. So it's very possible that they're advanced. Not only that, there was a rumor, as yet unconfirmed, in 2008 that we actually received a radio signal that was a message from Gliese 581G. Now, it's a little skeptical because the people who found the signal are not releasing it to anybody. And so there's been absolutely no verification on that since 2008 whatsoever. So if any scientist had actually found proof of the first alien transmission, you better believe we would have been all over the place with that because we would want the recognition for it. But, one way or another, we've sent the message. It should arrive in 2029. So in the next 10 years or so, they will actually know if there are aliens there, they will know that there are humans on Earth that are trying to talk to them. And then, you're looking at another 20, 30 years for us to try to get a reply from that. Other messages that we've sent, 55 Cancri, that's in Cancer, arrives in May of 2044. We've sent one to 47 Ursa Majoris, which will be in May 2049. Both of these are also habitable worlds. And also 37 Geminorum, which is in Gemini. So this arrives in 2057. So we've got a number of signals that have been sent out. They're out there. They're not coming back. We can't take it back. So we've told them who we are, where we are, and what we're like. All we can do is just hope that the people who get that are going to be friendly. Yeah, we'll see. So when we're talking, we've sent out some physical messages attached to the Voyager 1 spacecraft. There's a record, basically, that has greetings from everybody on Earth. It was launched in September of 1977. It has already left the solar system. It left in August of 2012. Its sister ship, Voyager 2, is actually moving a little bit faster, so it's actually catching up, but it left the solar system now in 2018, moving in a different direction. Our first message that we sent out, however, was Pioneer 10, and this was launched in 1972. This was the first spacecraft ever to actually travel across the asteroid belt. So this is one of our very first explorations out of the main part of the solar system. It did reach Jupiter, sent back our first pictures from Jupiter. The spacecraft is now dead. It stopped talking to us. The last signal was received from it in 2003, but it's still moving out into space. The nearest star that it's going to pass it'll pass within 3/4 of a light year or so. That's fairly close. Probably enough that any aliens there would see it, but it's not going to get there for about 90,000 years. Still, this was the first time that we had to think about how are we going to make a message that could actually be understood by aliens. I'm going to blow up the plaque here just a little bit. So this was actually designed by Carl Sagan's wife. And she was an artist. And so this is the Pioneer spacecraft right here. And we'll show all the details of the different things. But then we've got two humans here. So let me ask you, what is the guy saying here? Well, we hope that he's saying hello, but in alien, that might be, I'm coming to blow up your planet or something like that. And that's actually kind of a problem because different gestures mean different things, even to different cultures here on Earth, much less to a totally alien culture. The other thing that people noticed about them is, well, they're naked. And this caused a big stink because, oh my gosh, NASA is sending porn into space. How could they? Well, I don't know how to tell you this, but every one of you was born naked, and you're naked under your clothes. Sorry to inform you of that. If we had put clothes on these people, what do you suppose the aliens would assume? Well, they'd assume that was your hide, that was your skin, that was you're made out of. But this is what you're made out of. This is what you look like. This is who you are as a species. So, yeah, Americans are pretty much the only ones who have a problem with nudity from that. But we basically needed to show them naked because our normal, natural form is to be naked, and the aliens need to see that if they're going to interpret it. Now, a little more valid criticism of this, when the art was drawn, it was drawn in color. And the idea was to take facial features and and skin coloring and all that, so that we had kind of a blending of all of the different types of people that are on this planet. The problem is when you etched it in black and white, they look Caucasian, don't they? And Caucasians are not just a minority; they are a tiny minority of people on this planet, and they're certainly not representative of the average human on here. So that was a justifiable criticism that people really didn't think about until after it was already made and launched. They go, oh, maybe that wasn't such a good idea. That's why when we launched the Voyager spacecraft, it's got a record that has greetings from in every language on Earth plus whale songs. So that's a lot more representative and inclusive of who we are as a species. So let's look at this. Let's see if we can figure out what's going on. So right up here is this is a hydrogen molecule. So we've got one proton with one electron, and so that's a hydrogen atom. Hydrogen itself is a gas, so it's H2, and so that bond right there represents a hydrogen molecule. Hydrogen is the most common element in the universe. They are absolutely going to recognize that. So this then shows that 21 centimeter line that we were talking about before. Right here, this is the sun with arrows showing lines to the 14 nearest pulsars. These are rotating neutron stars. They send out a very regular beep signal. And then the periods and the distance are actually encoded in here. You can't really see it very well, but this is actually encoded in these multiples of 21 centimeters, and then shows the distance and direction by the line. So think about it. They're standing out here. They go, oh, okay, so that pulsar that has this frequency is over here. This pulsar that has this frequency is over here. This one's here. And we know that they're coming in from that direction. They can figure out which star we're from. So this is one of the best ways to actually navigate out in the galaxy from there. Then to give them a little bit of backup, then this line shows the direction from those pulsars and the sun towards the center of the galaxy. These are the inhabitants of Earth. These are the humans that we talked about. The height of the woman is listed here in these multiples of 21 centimeters. And of course, as you can see, we've got the diagram of the spacecraft. Well, they've got the spacecraft with them. So they've got something that they can use as a backup and go, oh, okay, so if this is 21 centimeter, then the woman should come out to be this big. Oh, look at that, she does. So that's a real important thing when you're trying to design a message to go out to alien civilizations, is you want redundancy. You want things to work together to reinforce so that they know that they've got the right idea as they're moving through. So this is the solar system down here. The distances are to scale. They're in units of 1/10 of Mercury's orbit. Shows the path of the spacecraft. It went past Jupiter and then went sailing on out. So now they can see that it was launched from Earth. So once they find the sun, then they know we're actually on Earth here. All right, so that's it for this one. Go ahead and get your practice worksheets. Work through that. Interpreting the messages is a little more difficult than you might think. So one of the things that we look at when we're trying to send out like the Arecibo message was, if we want to send a picture, we need to send an X and a Y coordinate with that. So how do we know, if we're only able to send out a stream of pulses, how do we know how big we need to make the message? How do we know how to tell them, okay, make it 10 by 20 or something like that? Well, it turns out one of the best ways to do that is actually with prime numbers. Because let's say we send out, let's see, 3 is a prime number and 7 is a prime number. So let's say we send out a message that has 21 pixels that are either on or off. Well, the only way to get X and Y from that is 3 times 7. So then they just need to decide, is it 3 times 7 or is it 7 times 3? And they'll be able to figure out how the message. They just try both ways and see which one makes sense. So that's a hint for your practice. Take a look at that and see if that helps you. Okay, guys, so that's it for this one. Hopefully you've gotten kind of an impression of how difficult it is to figure out how are we going to communicate with somebody who may be radically different from us. I mean, think about here on Earth, even with the different languages that we have on our planet and the different cultures, a lot of miscommunications happen. And we're all the same species, right? We're not fundamentally all that different. So now trying to communicate with a species that is extremely different from us, and they almost certainly will be very different from us, is a pretty big challenge. So if you wanted to design a message to send out to aliens, how would you do it? How would you do it in such a way that you could be sure that it wouldn't be misunderstood and that your message would get across? Something to think about. We'll see you next time.